Right, the end of topic test question 2. We've got a practical design. This is the number of square tiles used in the design, obviously around the outside of each garden. 7. First thing, of course, we do is look at the difference. Draw it in on your page. So adding another 4 there would be 19. We could put another one in as well, just to be sure. That will be 23. Right. The first difference is the same. So write that down for revision for yourself. First difference the same means it's a linear pattern. That will mean a linear rule. So it will have the form ax plus b, or we sometimes say mx plus c. Find how many square tiles Peter will need to make a design where the centre of a garden has side of 10 units. So design 1 has 1 unit. Centre of the garden. The centre has 2 units. This has 3 units for the centre of the garden. And so obviously if we've got 10 units, that would be design number 10. So we're going to need a rule. That 4 also tells us what we're multiplying by. And then we're going to have to make an adjustment. So 1 times 4 is 4 plus 3. 2 times 4 is 8 plus 3. 3 times 4 is 12 plus 3. So if we've got 10 units, we're going to need to go 10 times 4 plus 3, which equals 43 tiles. Alright, next question. Write an equation, and obviously we've just worked that out. So capital T is going to equal n times 4 plus 3. And in algebra, if you want to tidy that up, we'd probably write 4n plus 3. Right, next question. I think we're down to draw the graph now for the number of tiles. So design 1 used 7 tiles, 2, 4, 6, 8. We're going up in steps of 2. Obviously you'll be able to draw it a lot clearer than me. Second one used 11. Third one used 15. So we're going up in steps of 4 across 1, and we're going up 4. So if it's 5, 23, it's just a guess. 7, 4 sevens are 28, D1. You can make sure yours is accurate. Right, it's a practical pattern. So make sure you haven't joined it. Don't join. There's no such thing as talking about 1.5 tiles. Along the bottom here is the design number. Sorry, and this is the number of tiles here. Make sure we understand that. Explain how now this is the tricky question, needs some explanation. Explain how the equation and the graph relate to the number of tiles surrounding the gardens. So we try to have at least 3 valid comparisons or explanations. So if we just remind ourselves, the equation would be T equals 4n plus 3. We've got the graph above, and we want to know how that relates to the situation of the tiles. Well, perhaps we can begin by saying the design number is discrete, which is why we use points on the graph and not a line. Design number is a whole number. Another word for that is discrete, but we'll use as a whole number. So the points are not joined. Right, looking at the gradient there, obviously for each extra design we're adding 4 more tiles. For each extra design we are adding 4 more tiles. This would be the gradient of the graph. The gradient of the graph, and we can see it in the equation. As well. So we've talked about the gradient, always good to talk about the y-intercept. Now it doesn't particularly make sense in this case. Y-intercept would be 3, but you can't really talk about design number 0. You should still, so perhaps we won't mention that. Yes, we will still mention that, just to show the y-intercept would be 3, and in the equation we can see that. However, this doesn't make sense in a practical situation. Doesn't make sense practically. To talk about n equals 0, or in this case it would be design 0. Right, and next question there. It says Tony has got 233 tiles. Calculate the size units of the biggest garden Tony could surround using these tiles. Explain your method. So 4n plus 3 gives me the number of tiles, and in this case it's 233. So we've got a little equation to solve here. And just setting that up as part of the explanation. Obviously we'll minus 3 from both sides, and then we'll divide by 4. You get 57.5. Now you can't have design and a half, so what I would do to check is just check when n is 57, see how many tiles, and I would also check n is 58, just because of that little 0.5 there. So if n is 57, we need 4 times 57 plus 3, which gives us 231 tiles, and 4 times 58 plus 3 gives me 235. I don't have enough tiles to make that garden, so the biggest garden possible would have 58. Oh, would be design number 58, so that would have 58. Well, perhaps we'll write would be design 58. A 57 would be design number 57. Right, part F, give the rule for the total sum of the number of square tiles people would need S if he made n designs. So we need a table. If he made the first design, we're going to need 7 tiles. If he makes the first and the second designs, he'll need 7 plus, for the first one, plus 11, which is 18. If we made the first and the second and the third design, we'll need to add on another 15 to that for the third design, which is 33. Let's watch what's happening here. So I'm adding 11 onto that one, adding 15 onto that one. So the next one we'll need to add on 19 to get the next one. +33 plus 19. 32. That's for making 1, n2, n3, and that's 4. Now we'll start looking for a rule. So I can see that the first difference is not the same, so it's not linear. The second difference is the same, so that means it's going to be a quadratic rule. And we jump over onto our calculator and we put some points in. Seven, 18, 33, hover over F1, and now we need to choose, it's quadratic, so we need to choose x squared. We'll copy down what it says, y equals ax squared plus bx plus c. Now a is 2 and b is 5, c is 0. We'll have a go at using the lettering they suggest. So we want S to stand for the total, and N, of course, this is N, and here is S for the sum, and C was 0. 2n squared plus 5n. We can always check that by going into table, putting that rule into table. Let's go over to here and work out how we could check that. A table in this calculator is number 7. So we'll put in that rule, 2 times x squared plus 5 times x. And notice you put the time signs in. 5 times x. And we'll set that. 1 to 5, that's enough. 7, 18, 33, so it's worked. We'll just put a square around that.